Welcome. In this lecture, we are finally going to be connecting that aiming with raycasts and the ballistics so that we can use it to aim and shoot like I'm currently doing in this game. So we'll be taking a proper look at how you call raycasts and what the raycast function actually looks like and how to use it. So let's dive right in. So one thing you may have noticed when trying to play is that if we select our cannon, set a sensible launch velocity, and try to actually manipulate this value here, it behaves in a very, very strange way, and it doesn't seem to correspond really with the coordinates we're trying to use. So if I set things further away, it seems to be swinging off in an arbitrary angle. Now you might be a bit confused as to why that is, but I have the answer for you. The cannon here is rotated. That shouldn't be a problem. However, the fact that its barrel underneath it is rotated, that would be a problem, and the rotation in here. So let's just reset our rotations here to 0, 0, and 0. That's on the cannon itself. And then on the barrel, yeah, you notice that the rotations are 0. However, by convention, Unity's forward direction is in the Z direction, which is this blue arrow. And we can see that the cannon is clearly not pointing down the forward direction. So we have to take our projectile spawner and barrel and rotate it by 90 degrees to be pointing down the forward direction, quite simply. Now if we tweak our barrel slightly so that it's exactly at 90, and we don't need this to be at minus 360, we can just have it at 0 and 0 just for simplicity. And finally just tweak the position of our spawner so that it's still at the butt end of that barrel. And let's go and check that it's all aligned. Looks good to me. So I'm going to save that and hit play. Now what we get, let's go to our cannon. Okay, we need to set an initial launch velocity because that's getting annoying. So I'll stop playing. I'll set my launch velocity to 100. And now let's hit play. Okay, now it's pointing in a forward direction, which makes more sense. And as I make a forward Z direction, that's making sense that we're going over here. A negative is in that direction, as we saw in our scene, because Z is pointing away from our target. That's just the way we set things up. And moving left and right seems to work. Going negative goes over to the right and positive goes over to the left, which is also what we saw in our coordinate system with X pointing over here to the left. So negative X does make sense that it would go towards the right. So now our barrel is making a lot more sense at why it's aiming. However, I did promise you that we'd be doing this with raycasting, so let's have a look at what we've got there. For raycasting, if we go to Physics Assets, then we go to Aiming. Now you'll notice I've zoomed out a little bit so we can read the entirety of these names. A bit counterintuitive that you have to zoom out to read the names, but that's kind of helpful. We have a Ballistics Aim component, so I'm going to open this up and see what it does. So in Visual Studio, you can see that this line here, the one where it says physics.raycast ray, out hit info. This is what we're interested in because that is the Raycast API call. Now the first parameter of this is array. The array is constructed up on this line here. The crucial bit of information is that we have transform.position. So it is taking the position of the object that it's dropped onto, and it's going in the direction of the transform.forward. So if you hover over ray, you'll see that it takes an origin and a direction. So that makes sense for array because it has a position and it goes in a direction. That's how we raycast out. So it takes in that ray. It also takes in something prefixed with the letters out, with the keyword out. And that means that this object isn't actually an in parameter. It is something that we're getting back out of the raycast. It's the information about what we've hit. So it's this of type, of class, raycast hit, and that's what we're getting out here. And it has some interesting properties, such as point, which is the point in space where that hit has occurred. The other interesting thing you'll notice is that the raycast thing itself returns a Boolean type. Let me hover over it properly. Yeah, there you go, returns a Boolean type. And that is because if it doesn't hit anything, it's false. So this code inside the brackets doesn't get called if it doesn't hit anything, so we're not going to be updating the solver target. So there is this solver target. We're not interested in it right now. What we want to do is just print out the value of hit info.point so that you can get a sense of what this is doing. Now, what object are we going to stick this on? Well, the main camera, because we're going to be projecting the ray from the origin of the main camera down the looking direction of that main camera. So now if I move around, go into my console, you'll notice that indeed, as I move my gaze to the left, the X grows, and as I move to the right, it decreases. As I go up, Y increases, and as I go down, Y decreases, and Z stays the same because we're looking at a plane that is perpendicular in the Z axis. But I won't bore you too much with that detail. So now we have that ballistics solver, and you can notice that we also take a reference to a ballistic solver here, which if we look at our component on the main camera, is currently not set. So this is a challenge for you. Let's hook up the ballistics components. I would like you to connect the ballistic aim to the ballistic solver, get a sensible value for launch velocity. You can do that by eyeballing it, or you can use this special script that is called projectile debug. You just need to drop that onto your projectile prefab. And then you can tweak the parameters to get the hit to be right there in the center of what you're looking at. So pause the video and see if you can manage this challenge. Okay, welcome back. So we are going to try to hook up those two ballistics components. So the ballistic solver, in case you'd forgotten, was on the cannon, and the main camera was on has the ballistic aim. So if we go into Visual Studio, we want to remove this print statement. And now it should start to make sense that the solver.target is being set from the hit point that we find by raycasting. So when we give it the reference, it should basically hook up and all work. So I'm going to pull this cannon, drop it onto the solver reference, save that, hit play, and now when we look around, you notice that the cannon is turning to point and look at the point in space that we are looking at. So now it doesn't quite hit the point I'm looking at, and the reason for that is because if I look at my cannon, my launch velocity is much, much too high. And in reality, we're not launching at that speed at all. And how do I know that? Well, let's use our debug script to verify this. So I'm going to go to the projectile folder. There we have projectile debug, and I can just drop that onto my projectile prefab. Now, if I hit play, when I launch, you notice that I get these velocities created. And that's what I want to pay attention to. As I launch, I am going to see that the mean velocity is around 19.9. So that should be what the launch velocity is. So I go to my cannon, I change my launch velocity to 19.9, and I hit play. Now, when I fire, you can see that the projectile is indeed hitting the center of what I am looking at, which is much, much better for the gameplay. Excellent. So we've achieved that challenge. When you're ready, move on to the quiz questions and then subsequently the next lecture.